Hi guys. Okay, today I'm going to actually teach you about equilibria, and I'm going to actually show you about equilibria maybe by using some diagrams, okay, so that you can easily understand. So let's actually start. Okay, so when it comes to equilibrium, okay, equilibria happens in any chemical reactions that are reversible. Okay, it means that they have both forward and reverse reaction. Okay, for example, if you have Haber process, nitrogen plus hydrogen, okay, to give you ammonia, that is one example of a Haber process. So I will write down the equation here, N2 plus 3H2. So it is represented by this equation. So this is a Haber process. And do remember all the uh, reversible reactions, okay, when you leave it to react, okay, the reactant and product, they will come into equilibria. So what is equilibria? It's a state, okay, it's a state where they are going to actually satisfy four criterias. Okay, so I'm going to actually use this diagram, like for example, just imagine, okay, equilibria, okay, is going to be represented by this heart of this girl. Okay, so you have this girl and then the heart. Okay, so three people trying to win over the heart, okay, of this girl, and they are exerting equal amount of effort, okay, to actually get and try to win the heart of the girl. Okay, now in this case, okay, the heart of the girl, okay, remains at one particular place. Okay, it doesn't actually go to that particular person and so on. It just because it's going to be at equilibria, okay, it's going to be not moving at all. Okay, it just stays there, something like your physics. Okay, when you have something that is giving equal amount of forces being pulling it at different direction, equilibria can be achieved, okay, where the resultant force is zero. Okay, but in chemistry it's going to be something like that. So we are going to any particular reaction, like for example Haber process, they will satisfy equilibria if they have four particular factors. If they actually satisfy these four criteria, then we can actually say they are at equilibria. Number one, okay, the number one, the system must be in dynamic. It means the reaction, okay, is going to be continuously happening. The reaction doesn't stop. Okay, it means that this person A, this person B, this person C is keep on trying to win the heart of the girl for like maybe 3 years, maybe 4 years, 5 years. They are still trying, okay, and then the girl is keep on rejecting them. So that is going to be a dynamic system. They are going to continuously react. When you refer to chemistry, nitrogen and hydrogen is going to be producing ammonia, and the ammonia continuously going to be producing hydrogen and nitrogen. So they are going to be dynamic. The reaction do not stop at equilibrium. Okay, the second part is going to be the rate of forward reaction. Okay, the rate of forward is going to be the same as the rate of reverse reaction or backward reaction. Okay, equals to rate of backward reaction. So it means that, okay, if let's say, okay, this is reversible reaction, for example, the rate to convert nitrogen to become ammonia, okay, nitrogen and hydrogen to become ammonia, the rate is going to be the same as the conversion of ammonia to become nitrogen and hydrogen. So the rate is going to be the same. So that is going to be another criteria when we look at equilibria. Equilibria will have the same rate of forward and backward reaction. So what is number three? Okay, number three is going to be once they achieve equilibria, the concentration, okay, of the reactant and the products are going to be constant. Constant doesn't mean same, okay, but it's constant. It doesn't change. Like for example, the affection of A towards the girl, the affection of B towards that girl, the affection of C towards that girl, even after so long, 3 years, 30 years, is still going to be the same. Okay, it's still going to be constant. They don't change. Okay, so they still going to be reacting, and then the rate. Okay, since the rate of the forward and backward reaction is going to be the same, the concentration remains constant. Let's actually try to apply to the chemical equation over there. Like for example, nitrogen, the concentration of nitrogen, the concentration of hydrogen, the concentration of ammonia, they are going to be constant. They don't change once they reach equilibrium. Yeah. So number 4, okay, all these reaction must happen in a closed system. So what is closed system? A closed system is a system where there is nothing being added into the system and nothing is actually coming out from the system. So if you want to represent this in this, let's say, for example, this relationship, okay, to remember this. So it means this is a love case that is going to be some kind of close, okay? There are no, okay, let me draw properly, yeah? So there is nothing that is going to be changing, okay? In this case, it's just a love situation between these 3 guys and the girl. Okay, so it means nothing is changing over here. No new guy, no guy D comes in into the situation, and no new girl coming in into the situation. So it's closed. Nothing goes out, nothing comes in. So it's a closed system. So what happens, okay, if you have, let's say, for example, an open system. The open system, let's say there is an open system. So let's say guy C saw another girl and he fall in love with this girl. So he will go towards this girl, and what is going to happen, okay, there is going to be the equilibrium, okay, is going to be closed only, okay, with these 2 guys. So it means now earlier just now there was an equilibrium, but because something went out, okay, because there's an open system, okay, when something went out, a new equilibrium has to be achieved. So earlier, let's say they are putting their effort at 120 degrees and so on. Now a new equilibrium is going to be achieved where they are going to actually pull the girl maybe in 180 degree situation. So the way they are approaching is going to be different, okay, when there's something change over here. So basically when you remove something, okay, you need to remember once equilibrium is achieved, okay, when you change the equilibrium, okay, the system in equilibrium, there is going to be a new equilibrium going to be achieved. So how it can be done? It can be done by shifting the position of the equilibrium, which we will learn later. Okay, so it means just remember here when it comes to equilibrium actually goes along with these 4 things. Dynamic, okay, in equilibrium it must be dynamic, continuously reacting. Rate of forward equals to rate of backward reaction. Concentration is always going to be constant, okay, for system in equilibria, and it must be happening in a closed system. So this is going to be very, very important, and that's it for today's lesson. Thank you guys. See you. Bye.